cocaine's journey in your brain. What is cocaine? Cocaine is defined as an addictive drug derived from the coca plant or prepared synthetically. It is also used as an illegal stimulant and sometimes it's used medically as an anesthetic. Here is a chemical structure. Then, this is a molecular formula and molar mass.
Cocaine is an agonist, which is when the drug increases neurotransmitter activity.
Short and long-term effects. Some short-term effects include loss of appetite, increased heart rate, issues with blood pressure, increased rate of breathing, dilated pupils, disturbed sleep, and nausea. Well, this picture is getting drawn. It shows the effects of chronic use of cocaine.
Neurons and their interaction with the brain. Neurons fire signals to the brain. A flow of ions in the cell membrane create a tiny voltage which is known as a neuron impulse. The neuron impulse is a wave of electricity that travels through the end of one axon into another. This wave of electricity, also known as an action potential, helps speed up the sending of the signal. Neurotransmitters such as dopamine are later released from the axon terminals into the receptor sites of the targeted neuron. These receptor sites only accept specific shaped neurotransmitters, just like a lock only accepts a specific shaped key. The neurotransmitters then bonds to the receptor sites, causing the cell to be stimulated. The surplus neurotransmitters undergo a process called reuptake, which is when they are absorbed back into the system to be saved for later.
Dopamine. Dopamine is a primary neurotransmitter that interacts with cocaine. Here is a chemical structure. Did you know that both of the structures of cocaine and dopamine have a single benzene ring? And this is a molecular formula and molar mass of dopamine. Cocaine and dopamine.
Dopamine is the primary neurotransmitter that interacts with cocaine. The dopamine transporters are in charge of absorbing the dopamine neurotransmitters back into the cell. When cocaine is within the circulatory system, it blocks the dopamine transporters, impeding them to absorb the dopamine neurotransmitters back to the cell. This causes dopamine neurotransmitters to be stuck in the synaptic cleft, bonding over and over to the receptor sites, overstimulating the cell.
Equilibrium and cocaine. equilibrium is a state in which opposing forces are balanced. In this case, in the body, it is known as homeostasis.
As an agonist, the presence of cocaine impacts the equilibrium present to produce its observed effects by increasing neurotransmitter activity. As mentioned earlier, the dopamine transporters that absorb the neurotransmitter back into the cell are blocked, and the neurotransmitters are trapped in the synaptic cleft. This causes the dopamine neurotransmitters to bond over and over with the receptor sites, causing the cell to be overstimulated. Therefore, the system is stressed and there is a right shift because the rate of the forward reaction increases.
The shift in equilibrium after long-term use. The neurotransmitters stuck in the synaptic cleft are binding over and over to the receptor sites. This makes the receptor sites stay highly active. This causes the brain to think that there is enough dopamine in the body. As a consequence, the body stops producing these neurotransmitters. However, the cell has no dopamine in its vesicles. The neurotransmitters are no longer being produced in the body, and low levels of dopamine can eventually lead to depression.
Your journey is done. Now that you know what cocaine does to your brain, don't go try it.